On to number 15 and 16. This is where we have these word problems that you're trying to make into equations. A reminder, big deal reminder. You will have one of these on the free response section, and it'll have a table with it. And the table you're going to have to fill out, but you can't fill out a table if you cannot get the correct equation. Okay? Now, I would strongly, wink, wink, nudge, nudge, strongly expect it to be one like number 16, where you're putting something in slope-intercept form. But the first time we learned this, we learned by putting them in standard. And I'd say the standard ones are probably a little bit easier, okay? Because it's usually two items that are kind of paired together. It'll tell you which variables to use. They're pretty self-explanatory. But the ones that go into slope-intercept, like number 16, are more difficult because they have a rate and they y-intercept. And it's easy to get these backwards. And it's easy to get the rate with the wrong sign if you're not reading the problem correctly. So number 15 should be the easier one. Let's see how we do, okay? Selling hot dogs for $2. Well, I'm already kind of pairing these things up in my mind, and it said to let H represent that. I keep on scanning burgers for $5, okay? And it said to let B represent that. And then our big final number is C. It's the total. It's what we want to earn, okay? So that means it's $2 per hot dog plus $5 per burger equals our total cash value of $500. So I just kind of paired the stuff off in my mind. I'm looking, okay. 2 hot dog, 5 burgers, 500. Ooh, double check, be careful. 5H plus 2B, I just reversed those and gave you an option with the numbers backwards. Careful, guys, I cannot stress enough. Be careful on this test that you are selecting the correct answer. Nothing hurts me worse than seeing someone with the right answer written down and then they bubbled in the wrong answer. I can't help you there. You got to bubble in correctly. On to number 16. We read through. A backyard pool contains 300 gallons of water. It is drained at a rate of 6 gallons per minute. Let Y represent the amount of water and X represent the time. Okay? So this would be kind of our independent-dependent sort of situation. But we're reading on through here, and we're looking with it in our mind that we're going to find a rate, which is otherwise known as a slope, and then we're going to find a y-intercept, which is kind of an initial value, like a starting point. So if you don't like initial value, think of it as starting point. So we're talking about this pool, and it tells us straight up, it says, hey, we're starting at 300 gallons, kind of like with our plane. Our plane either started at 0 when it was on the ground, or it started at like 10,000 feet, okay? Or like a bank account, it can start with an amount in it, all right? But this pool starts with 300 gallons, so that's what I'm thinking of for my y-intercept. So I'm thinking my equation might be y equals something something plus 300. And I keep on scrolling because I'm looking for a rate, and then I see it. Rate of 6 gallons, okay? A rate of 6. So people, this is where they get confused. They jump to the conclusion. They say, okay, 6x, boom, done, answer, good to go. But it's not. You have to understand what you just said with that mathematical equation. We want our pool to be drained at this rate. That means we need our total amount of water to be going down, which means we need a negative slope, okay? The idea that this pool is being drained causes a negative slope here. If it was being filled, it would be a positive slope. But we need, as time progresses, to be going down in our total. And that's what we've signified there. Number 17, this is the old cover it up sort of thing. A y-intercept, by definition, a y-intercept means the y is the important number. So the y can be anything, it's important. But the x is useless here. It's always 0. And I just said it's useless, but I just put a number down too. I just said it's useless, but it's what gives us all the power in this equation. If I know that x is 0, I can plug that information in. That is 3 times 0 minus 5y equals 30. In other words, this is why it's called covering it up. that whole piece just goes away. Divide by -5, divide by -5, find that y equals -6, and then I plug it back in here. So I should have 0, -6 as my y-intercept. That would be option A. Number 18, find the x-intercept of this. There's two methods to do this, and I'm going to show you both. Method number 1 is essentially what we just did, but in reverse, meaning that for an x-intercept, the x is important, it's in the name, and the y is 0. Well, if I plug that in, I get 0 equals 6x minus 54. I can add 54 to both sides, or subtract 6x from both sides, either way works. I get 54 equals 6x, divide by 6, divide by 6. I get 9 equals x, and I can plug that back in to give me the result 9, 0. And I did that. I did that for 2 of my classes. And then I got to 4th block, and they said, Mr. Sorrell, I just graphed it. Great. That's a great alternative way to do it. You hop in your calculator, you go in, you type in, you see I already have it up here, 6x minus 54, and you hit zoom 6 or graph. And I look, and it panics me for a little bit because nothing's happening. But something was happening. You got to understand this graph's starting down here at -54, way down in the middle of nowhere. And it's got to take it a while to climb up that high. So it finally does, and it crosses at 9, 0.